I think it's incredibly devastating when any patient walks into their doctor's office and they say, your vision has an expiration date. We don't know exactly what it is, but one day the world will go dark.
A young boy walks through a forest. The sky is overcast, there are trees, and a small clear stream. The trees are blurry and become harder to see until the screen goes black. Dr. Shannon Boy speaks to the camera from her office on the University of Florida campus.
My name is Dr. Shannon Boy, and I'm a professor of genetics and the chief of the Division of Cellular and Molecular Therapy at the University of Florida. So if you think about how important vision is, compare taking a hike through the woods in complete darkness to taking a hike through the woods, being able to see the vibrant greens of the ferns, being able to see the babbling brook, and imagine that going away.
The young boy explores the woods as the clarity of his surroundings switch from blurry to clear. He examines vibrant green ferns and places his hands in the stream.
That's the case for a lot of the patients that we're focused on developing treatments for. When I started graduate school, I fell completely in love with gene therapy and with the eye, and with the whole concept that if I worked hard enough, I might be able to develop a medicine that helped restore someone's vision.
The scene starts with Dr. Boy walking across campus. Then, a close-up of Dr. Boy looking directly into a microscope in her lab. The scene cuts back to a close-up of the boy in the forest looking at the camera.
So my job as a researcher has been to develop the tools that most safely and effectively can deliver that healthy gene to a patient's retina. When you have a headache and you take Advil, you're curing the symptom. Gene therapy is different in the sense that you're hitting the root cause of the disease. You are delivering back the gene that was mutated in the first place.
The scene shows Dr. Boy and her colleagues at work in the lab. The lab is modern and lit with blue and green accented lights. They use scientific machinery and discuss their findings.
You can think of that as a taxi cab. My job as a gene therapist is to make the best, safest taxi cab for delivering that gene or that passenger to the target cell. It's because of funding from the National Institutes of Health that people like me have been able to conduct the basic research that has led to the discoveries that ultimately are now being used to restore vision in people. The tools that we're developing for ocular gene therapy can be applied outside the eye too. And so you can see a scenario where that's not just useful in the retina, but it could be useful in the brain, in the heart, and various tissues of the body.
The young boy finds a dragonfly and swings from a low tree branch. Dr. Boy and her team discuss their research.
There are no secrets in science. When you discover tools with NIH funding, they are shared with the broader scientific community, and that results in a rising tide that lifts all ships and leads to more treatments for more patients. What motivates me, I think, the most to do my job is interacting with other moms that have young children that are suffering from these debilitating vision-robbing conditions. I have children myself. I know what it feels like to want everything for your child. You want them to thrive. It's hearing from the moms and dads of those little babies that have this condition that is, I think, the ultimate motivator for me.
The scene returns to Dr. Boy speaking to camera, cutting between this and the young boy in the forest, watching the natural world around him with wonder. End card reads, "Experience the impact of vision research. Visit NIH.gov.